Hey guys, Mr. Bowman here. Got the webcam going again, and we're also on Desmos. And what we're doing today is we are learning to identify and determine the equation of given log graphs. So log graphs, they're a bit new to us, but we have done some log solving skills to solve some algebraic expressions when we had unknown exponents. And we're going to carry on using this graph. And let's get into some examples. So the first thing I want to start off with is the power graph. So we've looked at this. So we know these are exponential graphs. We know that there's an asymptote at 0, and we know that reference point, it always goes through 1. Apologies, 0, 1. And that's because anything to the power of 0 is going to be 1. And we know we can move that point up, we can move it down, we can move it left, and we can move it right as well. And we need to remember that because today's graph, or the basic log graph, is actually the exact inverse of that equation. So what I'm going to do is I'm going to draw the line y equals x, and that line is actually going to act as a line of symmetry for today's graph. And if you think about it, that kind of makes sense because when we had unknown powers, we use log rules to solve it. So it makes sense that there's a relationship between the exponent graph and the log graph. So y equals x, that is our line of symmetry. And let's get into an example. So let's have a look at y equals, and just going to copy and paste this up here. Y equals 2 log x. Oh, apologies, that should be a small 2. So just start that again. So we'll get rid of that c for now, and then let's have a look. Let's change that b to a 2. There we go. So we can see the 2, or the base, sits within the log. The unknown power sits within the bracket, and we can actually see that idea of symmetry. That's perfectly symmetrical. At any point, it's the same. And the key thing that we want to note about the symmetry is, what is the reference point going to be for our new log graph? And that's going to be symmetrically the opposite of this y-intercept of here. So in our case, it's actually going to be the x-intercept, or the opposite number. So let's flip around that. So let's go 1, 0. And we've got that in our graph, and I'm going to label those points. And we can see those points are the opposites. They're the inverse of each other. The 1 and the 0 have been flipped around. And that's what the relationship between log and exponential graphs are. So hopefully we're developing an understanding. So the approaches, or the methods that we used for exponential graphs, about finding the asymptote and then using the asymptote to add 1 to identify the reference point, and then to figure out how much the reference point was moved left or right. The exact same approach is going to work for our log graph. That'll help us find B and C. And I just want to note, I've got A here, but we don't actually need to find A for that. That won't come up. And then we can mathematically calculate the unknown being the letter or the variable between the base, or the base of the log. So let's get through an example. Let's explain what that means, and then we'll go through a full start to finish example. So I've gotten all rid of that. We're going to ignore that A part because our ones won't be that complicated. So let's copy and paste this formula. So what we're going to do is, firstly, we're going to get rid of the C, and we're going to use log of the base 2. But that base can be any number. It can be 2, 10. It'll work out. So let's have a look at what that looks like. So this is our standard log graph. And we can see that key point, that reference point, 0, 1. Oh, 1, 0. That's there as well. So that reference points. So first thing we want to do is let's move that up or down. And we can do that by the usual deal, the +1. And we can also move it down by subtracting, and I've done -3. And we can see, if you look at the reference point here, that's been moved up 1, and it's also been moved down 3. So that makes sense. So same as our other graphs, our parabolas and our other things. And so let's get rid of these graphs. We can also move it left and right using the same methods as well. So let's do x. Let's copy that formula. Let's do +2. So that should move it to negative. It should move it across 2. So let's go 1, 2. Perfect. So that's moved that there, and we can also see the asymptote is now at -2, and that's really important. We'll use that to figure out the shift. And let's have a look. The asymptote is at x equals -2, and if we increase that by 1, we should be able to identify the reference point. X equals -1, and there you go. There's our reference point. It's just been moved across 2. There you go. So hopefully we can see that we've changed it by 1 to identify the reference point. Okay, let's give it another go. Let's try to move it in the positive direction. So let's go -3. And looking at the reference point, we can see that's been moved across 3. 1, 2, 3. And we can also see the asymptote is now at x equals 3. And if we add 1 to that, that means the reference point is now at x equals 4. So hopefully that makes sense. We've seen it, we've moved it up and we moved it down. The last thing we want to chat about is what does that 2 do? And like parabolas, cubics, all other graphs, that A can make it skinnier or fatter as well. So let's change that to a 3, and we can see how that's changed a bit. It's now a bit steeper. That's going up a bit faster. And let's change it to 0.5, and we can see it's like our exponential graph, it's flipped the other way. It's now a decay model. It's decreasing as opposed to increasing. So that is quite interesting. And the last thing I wanted to note was, and that was the domain of these graphs. So have a look. These haven't been moved left or right, but we don't have any negative values. So no negative x values down here. And just want to remind us, the reason that being, we learned it before, that base number, that cannot be 0 and it cannot be negative. So we won't have a 0 value and we won't have a negative value, but we will have everything above 0 for domain. So if we shift that left and right, that will impact the domain quite a bit, and no dramas. And in terms of the range, any y value will work and any x value down the bottom will also work. Hopefully you found this Desmos part useful.